NEC 210.19a addresses dwelling units, specifically stating that all 15 amp and 20 amp branch circuits in dwelling unit shall have their ampacities reduced to 80%. This means a 15 amp circuit is effectively limited to 12 amps, and a 20 amp circuit is limited to 16 amps. This derating is intended to account for the potential of continuous loads, which are defined as loads operating at their maximum current for 3 hours or more. In dwelling units, the likelihood of sustained high demand on these circuits is considered greater, hence the blanket derating requirement. Moving on to NEC 210.19 ATWO, which covers commercial, industrial, and other occupancies, the rules are different. Here, only branch circuits supplying cord and plug connected equipment that are not fastened in place shall have their ampacities reduced to 80%. This provision primarily targets portable tools and appliances that can draw significant current for extended periods. The rationale is that equipment that is moved around and used in various locations is more likely to be subjected to continuous use, therefore warranting the derating. The exception to this rule is crucial. The derating requirement does not apply to branch circuits supplying receptacles in commercial and industrial occupancies where the receptacles are not used for the connection of portable tools and appliances. Examples given include receptacles for general lighting, computers, and other electronic equipment. In these scenarios, the assumption is that the loads are less likely to be continuous or that the equipment is designed to operate efficiently without placing undue strain on the circuit. To summarize, in dwelling units, you must derate all 15 amp and 20 amp branch circuits to 80%. This is a broad requirement intended to cover the general use of these circuits within a residential setting. However, in commercial and industrial settings, you only need to derate branch circuits supplying cord and plug connected equipment that is not fastened in place, with the important exception for receptacles used for general lighting, computers, and other electronic equipment. Consider a typical dwelling unit with numerous 15 amp and 20 amp circuits powering various lighting fixtures, small appliances, and electronic devices. According to NEC 210.19 AON, each of these circuits must be treated as if it can only handle 80% of its rated capacity. Thus, a 20 amp circuit can only be loaded to a maximum of 16 amps. This might affect the number of lights or devices one can connect to a single circuit without risking overloads or tripping the breaker. Now consider a commercial office building. Numerous receptacles are powering desktop computers, monitors, and task lighting. Because these are not considered portable tools or appliances, the exception in NEC 210.19 ATWO applies, and the circuits do not need to be derated. However, if the office uses portable space heaters plugged into all receptacles, the circuits supplying those receptacles would need to be derated to 80% because space heaters are considered portable appliances. Let's delve deeper into the implications of these rules and how they affect circuit design and load calculations. When designing electrical systems, it's essential to accurately determine the expected load on each circuit. For dwelling units, you must always use the 80% derating factor for 15 amp and 20 amp circuits. This means that if you anticipate a continuous load of 13 amps on a circuit in a dwelling unit, you would need to use a 20 amp circuit to accommodate the load safely, as a 15 amp circuit would only be rated for 12 amps after derating. In commercial and industrial settings, a more nuanced approach is needed. First, identify which circuits will supply cord and plug connected equipment that is not fastened in place. These circuits must be derated to 80%. Next, determine if the receptacles are exclusively used for non-portable equipment like computers and lighting. If so, the exception applies and derating is not required. However, it's always a good practice to design circuits with some margin for future expansion or unexpected loads. Even if a circuit doesn't initially require derating, it might be prudent to use a larger wire gauge or breaker size to accommodate potential changes in the future. Also, it's important to consider the voltage drop in the circuit. Long circuit runs can result in voltage drop, which can negatively impact the performance of connected equipment. To mitigate voltage drop, you may need to increase the wire size beyond what is required for ampacity alone. This is particularly important for circuits powering sensitive electronic equipment. Furthermore, be aware of any local amendments to the NEC. Some jurisdictions may have stricter requirements or additional rules related to branch circuit derating. Always consult with local electrical inspectors or authorities to ensure compliance with all applicable codes and regulations. It's also important to properly label circuits in the electrical panel to indicate their intended use and any applicable derating requirements. This helps to prevent accidental overloading and makes it easier for future electricians or maintenance personnel to understand the system. Consider a retail store with several checkout counters. Each counter has a cash register, a barcode scanner, and a receipt printer, all plugged into a multi-outlet power strip. Because these devices are typically not considered portable tools or appliances, the exception to NEC 210.19 ATWO would likely apply, and the circuits supplying the checkout counters would not need to be derated. However, if the store also uses portable credit card readers that are moved around to different locations, the circuits supplying those readers would need to be derated to 80%. In a manufacturing facility, many circuits power large machinery, lighting, and control systems. The circuits powering fixed machinery generally would not require derating, as the equipment is fastened in place. However, circuits supplying portable power tools, such as drills or grinders, would need to be derated to 80% to account for the potential of continuous use. It's also important to ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the breaker and prevent electrical shock. Improper grounding can create a dangerous situation and increase the risk of electrical fires. In addition to the NEC, other standards and guidelines may provide additional information on branch circuit design and derating. For example, the National Electrical Manufacturers Association, or NEMA, publishes various standards related to electrical equipment and wiring. These standards can be helpful in selecting the appropriate equipment and ensuring that it is installed correctly. Furthermore, professional engineering organizations such as the Institute of Electrical and Electronics Engineers, or IEE, offer courses and publications on electrical design and safety. These resources can help you stay up to date on the latest technologies and best practices. Always consult with qualified electrical engineers or contractors for complex electrical projects. They have the expertise and experience to design safe and reliable electrical systems. Remember, electrical work can be dangerous if not done correctly. Always follow proper safety procedures and use appropriate personal protective equipment when working on electrical circuits. If you're not comfortable working with electricity, it's best to hire a qualified professional. Regular electrical inspections are also crucial for maintaining a safe and reliable electrical system. Inspections can help identify potential problems before they become serious and ensure that the system is operating in accordance with applicable codes and regulations. Be sure to schedule regular inspections with a qualified electrical inspector. In addition to the above considerations, it's also important to be mindful of energy efficiency. Use energy-efficient lighting and appliances to reduce the load on electrical circuits and lower energy consumption. Consider using LED lighting, which consumes significantly less energy than traditional incandescent or fluorescent lights. Also, be sure to unplug electronic devices when they're not in use, as many devices continue to draw power even when they're turned off. In summary, branch circuit derating is an important aspect of electrical safety and system design. By understanding the requirements of NEC 210.19 AON and ATWO and applying them correctly, you can help to ensure that electrical circuits are not overloaded and that electrical systems operate safely and efficiently. Remember to consider the type of occupancy, the type of equipment being powered, and any applicable exceptions when determining whether or not derating is required. Always consult with qualified electrical professionals for complex projects and to ensure compliance with all applicable codes and regulations. The 80% derating rule is not just about preventing overloads, it's also about extending the lifespan of electrical components. When a circuit is consistently loaded near its maximum capacity, the components can overheat, leading to premature failure. By derating the circuit, you reduce the stress on the components and help to prolong their lifespan. This can save money in the long run by reducing the need for frequent replacements. Moreover, consider the impact of harmonics on electrical circuits. Harmonics are distortions in the electrical waveform that can be caused by nonlinear loads such as electronic devices and variable frequency drives. Harmonics can increase the current flowing through the circuit and can also cause overheating. In some cases, it may be necessary to derate circuits even further to account for the effects of harmonics. Performing a thorough load calculation is critical before determining the appropriate size of branch circuits. This calculation should include all known loads, as well as an allowance for future expansion. It's always better to overestimate the load slightly than to underestimate it, as an overloaded circuit can be a safety hazard. Also, consider the ambient temperature in the area where the electrical equipment is located. High ambient temperatures can reduce the ampacity of conductors, so it may be necessary to derate circuits further in these conditions. NEC Table 310.15 provides guidance on ampacity correction factors for different ambient temperatures. Select the appropriate wiring method for the application. There are many different types of wiring methods available, each with its own advantages and disadvantages. Some common wiring methods include non-metallic sheath cable, metal clad cable, and electrical metallic tubing. The wiring method should be selected based on factors such as the environment, the type of equipment being powered, and the applicable codes and regulations. Finally, properly install and maintain electrical equipment. This includes ensuring that all connections are tight, that the equipment is properly grounded, and that the equipment is protected from physical damage. Regular maintenance can help to identify potential problems before they become serious and can also extend the lifespan of the equipment.